3. So there are two terms to kind of review at the top. And then we'll use the cross-multiplying method to solve 2 equations. And then we'll talk about other ways to solve equations. So if you're cross-multiplying, what does that mean you're doing? What would cross-multiply mean? Julian?
Isn't that like when you have 2 fractions and you multiply the numerator with 1? That's the denominator of the other.
Yeah. So he said you have 2 fractions that would be equal to each other. And you multiply the numerator of one, literally you go across the equal sign, and you multiply the denominator of the other. So this would become a times d. You still have the equal sign. And then again, you're doing the same thing. The numerator of the right, the denominator of the left. So cross-multiplying is one method, and we'll talk about 2, that we can use to solve rational equations. Cross-multiplying only works when we have one thing equal to another thing. So it does not work if I have an addition sign on one side, a subtraction sign, one fraction equal to another fraction. The other term that we've looked at in multiple sections, so chapter 6, chapter 7, chapter 8, all of them have extraneous solutions. What does it mean for us to have an extraneous solution? Deb?
Extra solution within the
Yeah, so extra, extraneous, extra solution that doesn't work when you plug it back into the original equation. In our case, each equation that we deal with, each family of functions, has a different reason why you could have an extraneous solution. With rational expressions, it's values that make the denominator 0. So when we were talking about logarithmic equations, it was values that make the log 0 or negative. So with rational equations, it's going to be whatever makes the denominator 0, that's going to be an extraneous solution. So on the front page here, we're going to just practice that cross-multiplying method to solve equations. Again, this only works when you have one thing equal to another, one fraction equal to another. So we can use the cross-multiplying method. Underneath it says make sure you check your original answer or your answers back into the original equation. You'll be asked to do a little check step just to make sure that we've solved them correctly. So Julian said cross-multiply numerator times denominator. So we're taking 20 times x minus 2. That denominator is a quantity, so that 20 has to be multiplied by everything in the denominator. And then the other side is the 5. That's getting multiplied by 2x minus 5. So you should no longer have a fraction. It doesn't get one fraction on top of the other, like it doesn't stay as just one fraction. You now have one equation equivalent to the other equation. And then we need to solve it. So if we're solving this, we would distribute the 5 and the 20 through, try and get x by itself. So essentially, you're taking a fraction and making it in that linear format, that horizontal format. So Julia, what would you get if you take x's to one side, numbers to the other? Yep. So she said move the 40 over, so you get 15. And then when you divide, what did 15 tenths reduce to? that reduces to 3 over 2. So we're going to check this to make sure that it works back into the original equation. Little check step here. You need to pull out that calculator to help. But we're taking 3 halves and plugging it in for each x. So 2 times 3 halves minus 5. On the other side, we have 3 halves minus 2. So just looking at the denominator part. 2 times 3 halves. Does anybody know what 2 times 3 halves is? Odette? Yeah, that's 3. So we have 3 minus 5. Over here, 3 halves minus 2 is negative 1 half. And 3 minus 5 is negative 2. So Odette, 20 divided by negative 2 is negative 10. What happens when you take 5 and you divide it by negative 1 half? You get negative 10. Remember, when you divide by a fraction, you're multiplying by the reciprocal. So it's really taking 5 times negative 2. So checked it, worked. This is a true statement. We can move on. X does equal 3 halves. Some of them are a little easier to check if you get whole number answers or integer answers. So solving letter B, doing exactly the same thing, cross multiplying. Easiest way to solve one fraction equal to another. So 4 times x plus 5 equals, be really careful with that other side, you now have 2 quantities. So we have an x minus 1, we're multiplying that by an x plus 1. So make sure you have like that quantity, if it's more than just a number, it needs to be placed in parentheses. So Abby, when you distribute the 4 through on the left, what do you get? And on the right, if you FOIL those two, what does that give you when you FOIL them?
X squared minus 1.
Yeah, x squared minus 1. So now we have a squared term in the equation, where the one on the left was linear. It's still in that horizontal format, but we have a squared quantity here, a squared term. How do you solve something when it's squared? Odette?
You set it equal to 0.
Yeah, we need to set it equal to 0. And then, of course, my all-time favorite F word, factor. So if I'm factoring this, Odette, if we set it equal to 0, what does it look like then?
X squared minus 4x minus 1.
Not 40. Matt, your all-time favorite F word is not factor? No, I think it should be. I mean, why not? So factoring this is the easy factoring, the shortcut AC method. We have negative 21. Connor, 2 numbers that multiply to be negative 21 but add to be negative 4. Yeah, so how about flip it? There we go, negative 7 and a positive 3. So one answer is 7. The other answer would be negative 3. And then I'm going to do a little check step for both of them to make sure they work. And it's a little easier because we're plugging in whole numbers into this, or integers into the original equation. But we have 4 and then 7 plus 1. We want to make sure that's equal to 7 minus 1 over 7 plus 5, so that's 1. And the second one is a negative 3, so 4, negative 3 plus 1. And then on the top, negative 3 minus 1, and negative 3 plus 5. So this is just plugging it in, checking, make sure that it's correct. The left side should be equivalent to the right. Every equation can be checked. So you can always check to make sure you have the correct answer. So here we have 4 over 8. And over here we have 6 over 12. 4 eighths is a half, 6 twelfths is a half, so that looks good. On the other side, we've got 4 over negative 2 and negative 4 over 2. And again, that checks out as well. Questions? I think there's 2 problems at the bottom of the page. See if you can solve those 2 problems. So again, solve by cross multiplying. Make sure you check your solutions. Will, what'd you get for the answer for number 1? So plugging it back in. We have 3 and -2. On the other side, we get 6, 12, -4. So 3 halves, -3 halves is equal to -6/4. So that's true. Kushal, how about number 2? What'd you get for that one? -5, is that what you said? Okay. Again, giving it a quick check here. So we have a -6 and a -3, a -12 and a -6. And 2 does equal 2. So that's cross multiplying. It only works when you have one fraction equal to another fraction. Anytime there's anything extra added to one side of the equation, you no longer can use that method. It's a pretty nice method to use. Questions? So if you flip the page, example 2 would be the other way that we're going to have to solve rational equations, and that would be using some of the methods that we've been working on. In this case, it says, as a little hint, we're going to multiply each side by the least common denominator. So in this case, just like the other, our goal is to get the fraction out of the problem. So with cross multiplying, in one single step, I guess technically 2 because you have to crisscross, you eliminate the fraction from the problem. Our goal is not to have the fraction. We want to have something that is in this horizontal format. So our goal is to take the least common denominator, multiply it to both sides so that we can get a fraction eliminated in essentially like one step. So I should go from fraction form to this horizontal format. So if we look at this problem, what is the least common denominator? So just looking, what would the least common denominator be, Holly?
3x.
Yeah, so the least common denominator would be each different factor multiplied together. So there's an x and there's a 3. It says to multiply each side by the least common denominator because it's an equation. It's no longer an expression. So I have to do the same thing to the left and the right. So we're going to take the left side and multiply it by the least common denominator. But I'm going to place it as a fraction over 1. I'm going to do the same thing to the right side. I'm going to multiply it by the least common denominator of 3x over 1. Now remember, our goal is to get a horizontal equation. So I should not have a fraction after I move from this step. And I'm going to show you technically what's happening here, and then we'll kind of do a shortcut to it. This 3x is going to get distributed to each piece of the problem, because anytime you're multiplying by something, multiplication with quantities really means it's distributing through. So I have a 3x over 1 times an 8 over x. Again, I'm just showing you this step so you can kind of see what's happening with the problem. We will not write this step again. And then I have a 3x over 1 times an 11/3. Distributing means multiplication, so I'm just taking the least common denominator, multiplying it through the problem. On the other side, we have negative 14 over x times 3x over 1. So if you look at the pairs of fractions and simplify those pairs of fractions, what would 3x over 1 times 8 over x become if I simplify that? Odette? Just 3 times 8, because the x here and the x in the denominator cancel. And that's our goal. Our goal is to get it out of fraction form. So by using this least common denominator, the part that's the same cancels, and we have a 3 and an 8 remaining, which gives us just the number 24. That's cross-canceling. That's what we did with that simplifying rational expressions. So then, Odette, looking at the middle pair, the part that cancels would be the 3. The other part that the denominator didn't have was an x, and that still remains in the problem, so that becomes 11x. And then one more time, Odette, on the right side, we have negative 14 over x times 3 over x, so the part that cancels would be the x. So essentially, the piece that's the same is getting eliminated. The part that wasn't in the denominator stays, and Odette, 3 times negative 14 is negative 42. This here is our goal. We're going to try and skip this step. So that we go from fraction to horizontal format in just one step by trying to use this least common denominator. So I can't cross multiply, but we can still use a method to help us get rid of the fraction. And now we just have to get the x by itself. So Julia, 11x would be equal to? And when we divide, we get negative 6. Now again, in little italics over here, the little stars, asterisks, we have check your answer into the original equation. So if I go back and check it into the original equation, I have 8 over negative 6, 11 over 3, negative 14 over negative 6. If you need to use your calculator, feel free to do so. But 8 over negative 6 is really negative 4 thirds. Negative 4 plus 11 gives us 7. Negative 14 over negative 6 is also 7 thirds. But use your calculator if you're hesitant with the fractions. Questions? So we're going to try and use this method again, but I'm going to try and get you to see how we can eliminate this step here. So if you look at the second problem, solve using common denominators. I'm going to take a 2 here and place it over a 1 just so that it's a fraction as well. So I want to have fraction, fraction, fraction. So it says solve it with 2 solutions. So we're going to have 2 solutions, 2 answers in this question. What would the least common denominator be? So looking at the fractions, Maddie, what do you think the least common denominator is?
X plus 3, x plus 4.
Yeah, x plus 3, x minus 4. So using the process above, because it's an equation, we're going to multiply the left side and the right side by this least common denominator. That keeps it equivalent. So I have x plus 3, x minus 4. And then the whole right side. So instead of showing that whole second step, we're going to see if we can skip that second step and just go to that horizontal equation. So if you look at the fraction on the left, we have 3x minus 5 over x plus 3. The least common denominator is going, or the denominator that's there, is going to cancel with whatever term it has in common with the least common denominator, because it already has that piece in the problem. So whatever part isn't in the denominator is the piece that gets multiplied with the numerator. So right now the numerator has a 3x minus 5. My denominator was x minus 3. So that part it already has in common with the least common denominator. The part that it's missing is x minus 4. So if I was getting a least common denominator, I'd have to multiply the top by x minus 4. We're still doing that. So you're multiplying by whatever part is missing, but we're taking the fraction out of the problem. The next one we have is a 2. The 2 only has a 1 underneath it. It doesn't have any part of the least common denominator. So it's going to need the x plus 3 and the x minus 4. Because that's what it would take for it to have a least common denominator. And then we have a plus 18. What does the 18 get multiplied by? What did it? 1. Because it already has the whole denominator. It doesn't need anything extra. The least common denominator is already there in the problem. So that 18, if you want to say it gets multiplied by 1, you can. Otherwise, you can think of it, it's not getting multiplied by anything. You wouldn't normally multiply by anything if you were trying to get a least common denominator with fractions. So looking to see what we have what was in the numerator, and then next to it was the piece that was missing from the denominator. So it was missing an x minus 4. The 2 was missing both parts. The 18 wasn't missing anything. So now algebraically, we got rid of the fraction, and now we have to try and solve this equation, which involves foiling first, and then we're going to have to do some factoring as well. So some of these problems get pretty involved algebraically because there's a lot of different ways that we have to work through algebraically to solve the problem. So see if you can do some foiling. Be careful with those signs. Foil first, and then we'll factor. I tried to do some of the algebra steps up here. So I did the foiling, combined some like terms together, distributed a 2 through. So Emma, if we take everything to one side, what do you have left if you set it equal to 0? I feel like I missed a sign somewhere. Nope, I didn't. We're good. 26 seems a little off, but no. So Emma, does that factor?
X minus 13,
Yeah. 13 and 2 give us 26. If they're both negative, it makes negative 15. So one answer is 13, the other answer is 2. Question. Good bit of work involved. The last thing, make sure you go back and check. And I know you've already done a ton of work to get to that point. Use your calculator if necessary, but go back and check to make sure that the 13 and the 2 are correct. Because there's an easy piece where you can forget a sign, miss a sign, multiply incorrectly. Use your calculator, make sure one is equal to the other. So 3 times 13 minus 5 over 13 plus 3. And then plugging in the 13 on the other side. 13 and 3 give us 16. 13 minus 4 is 9. And then you're taking 16 times 9. So make sure that one is correct when you're looking at those two fractions. Make sure they're correct. And then do the same thing when you plug in a 2. Just check to make sure that they are good. You did your algebra correctly. So we're going to just set up the next problem. I just want to make sure that you can get those pieces correct. We won't have time, I don't think, to go through and solve the whole thing. But let's just look at number 1. So solve the following by using the least common denominator. Make sure you check for any extraneous solutions. So let's look at the bottoms. Think about the least common denominator. There's a 4, there's a 6, there's a 2x. So Melanie, what would the least common denominator be? So look at the 4 and 2 first. It could be smaller. That would be a common denominator, but smaller. What else would 4 and 2 go into? Yeah. So 4 and the x. So looking at 4 and 2, both of those will go into 4. 4 divides into 4 once. 2 divides into 4 twice. And then there's an x. So that least common denominator would be 4x. So taking the left side, multiplying it by 4x. Taking the right side, multiplying it by 4x. So there's a 4 currently in my denominator. It's missing the 11. So 11x would be what's left for the top. So whatever part it's missing is what we need to multiply by. So this is missing an x. The next one has an x, but it's missing the 4. So that would become 11x minus 12. On the right side, it has a 2x, but it needs to be 4x, so I would have to multiply that one by 2. And this one's actually really easy to solve, because now we just have 11x minus 12 equals 10. On this worksheet, as you get down 17 and 18. So looking at 17 and 18 on the worksheet. Those two denominators are going to need factored first. The same process of finding the least common denominator holds true. The denominator has to be in factored form in order to find the least common denominator. So 17 and 18. Those two fractions on the right, you'll have to factor them first. please do this on a separate piece of paper. You can do it on the back, but to me, that's a lot of flipping back and forth. If you look at 8 and 16. So I'd like somebody to have 8 for tomorrow, Tatum. And look at 16. Someone else to do number 16. Shall we do 16? These are answers to today's homework and tomorrow's homework. So both worksheets that you'll have today and tomorrow, these are all the solutions to both of those worksheets. So Tatum, you have 8. Joel, 8, 16.